Hello there, everybody, and welcome to Geometry's Flip in the Classroom. And we are going to talk about today lesson chapter 5, section 4A, and then 4B, which would be part 1 and part 2. Okay? And we're going to go through both parts today. We're introducing 2 more lines. Okay? And then we're going to have an overview, which is more of what the second part is an overview of everything we've done so far up to this point for the lines of concurrency. We've learned 2 lines of concurrency. That was the perpendicular bisector and the angle bisector. And the point where all of your perpendicular bisectors meet is called the circumcenter, correct? And the point where your angle bisectors meet, the incenter. Now remember, this is a review from the beginning of the year. Now these are things that you should know. You know that perpendicular bisectors, you have to have certain congruency marks on the picture. Just like angle bisectors, you have to have certain congruency marks on the picture. So you have to be able to go forward and backwards. If they say you have angle bisectors, you put the where the incenter is, and if they tell you have the incenter, they have to be perpendicular. They have to be angle bisectors. If you have perpendicular bisectors, then it's the circumcenter. If they give you the circumcenter, you know all those line segments are supposed to be perpendicular bisectors. All right, so we'll continue with some things right now. And this one would be called medians. And medians, by definition, are line segments that start at the vertex and bisect the side across from it. Okay, so I'll draw that real quick. Medians are line segments that start at the vertex and bisect the sides across from it. So a median would look like this in an acute triangle. Starts at the vertex and bisects the side. Now that looks very close to a perpendicular bisector. The difference is it's not perpendicular. It doesn't have to be. A median is not going to be perpendicular. Sometimes it will, most of the time it's not. Okay? The big key about a median is that it bisects the side across from where you draw it. So if I were to have an obtuse triangle, actually we call that one a right one, and I'll call this one an obtuse triangle. Okay. And I want to draw a median here, it would look like this, bisecting a side. And then here's our last one, and I'm going to draw it here, bisecting a side. Okay. So the key is that it must start at the vertex and it bisects a side. Now, that's the opposite of a perpendicular bisector. Perpendicular bisector does not have to start at the vertex. It just has to be perpendicular and bisecting. A median must start at a corner, a vertex. Doesn't have a choice. Now, where do all 3 of the bisectors meet? Otherwise known as the medians. Where do all 3 medians meet? And hopefully know all 3 medians will meet at the centroid. Correct. The centroid is the point where all 3 medians meet. So now you have to know, okay, we have medians, and you know they all meet at the centroid. And if they say you have a centroid, that means all these line segments are medians. Now you gotta be careful because they look like or similar to perpendicular bisectors, but they're not. None of them have to be perpendicular. I will tell you this, all medians meet where? Correct. All medians will meet in the triangles. Just like angle bisectors meet in the triangle. Doesn't matter what kind of triangle, acute, right, or obtuse. All medians, the will always be in the triangle. The incenter will always be in the triangle. The one that doesn't happen is anything that uses the word perpendicular. They won't always meet in the triangle. So whether it be perpendicular bisector or, what you'll see in a minute, altitude, the other two must meet in the triangle. And two of them can meet in different spots. All right. So we have, what is a median? Correct. Line segment starts at the angle and bisects a side. What is a centroid? Where all the medians meet. And then what is our rule? Okay. Well, mathematically, our rule is this: that this centroid cuts this median into three pieces. This piece being 1/3, and this piece being 2/3. So that means the median is cut by 3. 1/3 is from the side to the centroid, and 2/3 is from the centroid to the angle. Well, why would this be important? Well, let's look at one of these as an example. In other words, the rule is the distance from the centroid to the vertex is 2/3 of the whole median. The distance from the centroid to the vertex is 2/3 of the whole median. Okay, so let's do a problem. Let's say you have a triangle, and here happens to be a median. But they give you the centroid, and they put it right here. All right, so they tell you that the entire median was 9 inches long. So from A to B is 9 inches long. So we'll go, measure of A to B is equal to 9 inches long. Notice we have a number value, so we write it as A to B. And we're going to call the centroid C. So I ask for, well, what is the difference from C to B? All right. Well, if I take the entire thing and cut it into 3 pieces, I know this is 1 piece, and this is 2, or twice as big as this one. So if I cut 9 inches into 3 pieces, that means I'll have one piece is 3 inches, and the other piece is 6 inches. Now the nice thing about this is you should see the relationship between this piece and this piece. The smaller piece is half the size of the bigger piece, and when you add them together, you get the entire median. So these problems work out really well when the number we're using is divisible by 3, right? So here's AB, it's 9, we divide it by 3, and we get 1/3 piece, which would be A to C is 3, and C to B would be 6, because it's 2/3 of 9. When you do that on your calculator, you get 2 times 9, which is 18, divided by 3, which is 6. This relationship happens all the time, and they can change it up. Say they give me this piece, 4. So here's a centroid, and this measurement is 4. Well, I know this is 1/3. So that means this is 2/3. Well, that means if this is 4, this is 8. And if I need to know the whole thing, it's 12. 1/3, 2/3, whole thing. All right, so let's look at another one. Let's say they give me this one is 10. Now here we are. From the vertex to the centroid is 2/3. And they gave me this as 10. This is 2/3. This to the side is 1/3. This is always smaller than this. So if this is 2/3 and I need 1/3, I divide it by 2 and you go from 10, and this side is 5. This side going from the side to the centroid will always be 1/3, or half of the other piece. And now the entire piece would be 15. And that's the additive segment postulate. Take this piece, and when you put them together, you get the whole median, which would be 15. So I'm going to do this for this one. And I'm going to tell you that the median is 21. From M to N is 21 inches. Tell me what it is from the centroid to the vertex. Now I'm hoping you took 21 and divided by 3. And that would be the smallest piece, which would be 7. The bigger piece is 2/3, so that would be 14. 7 and 14 make 21. So this is the math that you're going to have to pay attention to. It isn't difficult, but it can be confusing, especially when they start using all 4 of these types of things. All right, so let's look at the next type of problem, which is an altitude. An altitude starts at a vertex and is perpendicular to the opposite side. Okay, so let's look at 3 different triangles here. I'm going to look at an obtuse. So we start with the altitude for this. That means I'd start here and go here. That's what an altitude is. And this one will be a right triangle. This one's obtuse, right. So there's one altitude. Now when I go to draw this altitude, I can't go through the triangle and make a right angle. It's not going to happen. So we write an imaginary right angle. Okay, there's our imaginary right angle. And this is an altitude. Okay, this would be if I extended the side, there's the right angle. And now the last altitude we would need is if I took this last side and extended it, and I needed to draw a right angle. And there's my third altitude. Where all 3 of the altitudes meet, it's called the orthocenter. So here I have my 3 altitudes. Notice only one of my altitudes was in the triangle. The other 2 were out of the triangle. So I had one start from here and there, and then I had one start from here, and this was the extended side. Where all 3 of the altitudes meet, you have a orthocenter, right? And again, in an acute triangle, the orthocenter will be in the triangle. When you have a right triangle, the orthocenter will be the right angle. This right angle, because this is already an altitude and this is already an altitude. Well, why are they already altitudes? Because they both made the right angle. So in a right angle triangle, in a right triangle, when we were trying to find the circumcenter, remember it was always going to be on the hypotenuse. When we try to find the orthocenter, it's always right there. Always in a right triangle. It will always be where the right angle is. Why? Because that's where two of the altitudes already meet. So when I go to draw the third altitude, it's going to meet there too. So a right triangle, it meets on the triangle, except when we had circumcenter, it was on the hypotenuse. This one's on the vertex. Altitudes will always meet on the right angle of the right triangle. When it's obtuse, they're going to meet out of the triangle. They'll meet outside of the triangle. And that's when you extend the lines so that they all meet. All right? So hopefully everybody's caught up. So you have an obtuse, they meet on the outside. That's called the orthocenter. When it's a right triangle, it meets right there. That's called the orthocenter. And when it's a acute triangle, it again will be the orthocenter, but in an acute triangle, it will be in the triangle. So here's my right angle. There's my right angle. And it's going to be right there. Now, where do you have to be careful? Because you have 4 different segments now, and you have 4 segments that look or have pieces that resemble other ones. Like a perpendicular bisector bisects a side, but it has to have the perpendicular mark. Otherwise, it's just a median. But a perpendicular bisector does not have to start at the vertex, and a median does. Okay? And then we look at the overview of things. We're not really worried about any lengths in this problem. We're just trying to make sure we know where they can be concurrent and understand the difference between them. So let's look at something really quick as an overview. This would be what kind of line segments? Notice the right angle mark and the congruency marks. Those are all what? If you said perpendicular bisectors, you're correct. What are these all? If you said angle bisectors, you are correct. What are these all? If you said medians, you're right. And then last but not least, what are these called? They are called altitudes. These meet at the circumcenter. That's there, circumcenter. This meets at the incenter. This meets at the centroid. And this meets at the orthocenter. These two have rules for the distance. This one has the distance from the circumcenter to the corners is the same for an incenter, The distances from the in-center to the sides are the same. For this one, this median is cut into 2/3, or excuse me, cut into thirds. This being 1/3, this being 2/3. The distance from the centroid to the angle is 2/3. The distance from the centroid to the side is 1/3. So if you have one measurement, you double it, you have the other measurement, and you add them all together, you have the third measurement. If you start with this here with 8, cut it in half, you get 4, add them together, you get 12. Okay? That relationship never changes. And you have to memorize the difference between the 4 and how they change. All right. Have a good night. We will see you on Monday.